Good day, learners. So, I am Mr. John Russell L. Odeste, and welcome to our science lesson. So, for today's topic, we're going to talk about projectile motion. For today, our objective is relate the angle of release, the height, the range, and the time of flight of a motion. So, good day, learners. So, today we're going to talk about projectile motion. First, investigate the relationship between the angle of release and the height and range of the projectile. Our objectives are: define projectile motion. Second, relate the angle of release, height, and speed of the projectile. Third, solve problems of time of flight, range, and height of projectile using Phet Simulation. So, on this learning task 1, so let us answer this. Okay, everyone, eyes on the illustration. This is what we call the 4 pics 1 word. Okay, on the first picture, the man is trigger again. So on the second picture, the group of angry birds. On the third picture, do not pee sign, and on the fourth picture, there's a splash from the fountain. So what is the word? Alright, so if you got the answer projectile, you're correct. So let us unlock the difficulties or the terminologies in projectile. First, the word projectile. Second, trajectory. Third, height or peak. Fourth, range. 5, parabola. 6, projectile motion. What is projectile? Projectile is an object in projectile motion. What is trajectory? Trajectory is a path that projectile follows. What is the height or the peak? Height, that is the highest point of projectile. Range, it is the horizontal displacement of a projectile. Parabola, shape of the path of a projectile. And projectile motion is the objective presented under the influence of gravity. So, in the projectile motion, there are some factors affecting on it. First, the angle of release. In the angle of release, we have 2 dimensions. We have the horizontal dimension. Horizontal dimension, if the body moves or maintains its constant change in velocity. So, this is the horizontal dimension. The vertical dimension, it is a free fall body. Okay? And we have the angle of release. And on that angle, it's denoted by the degrees, or we can use or know the sign theta. So as you can see on that, you will be observing the angle of release. Alright. So, second factor is height. Projectile motion is affected by the height. So on this part, on that parabola, what is the height? Alright? Or the highest point or the peak of an object that is being projected. And the third factor is range. So range, this is the horizontal displacement or how far that the object is being traveled from the reference point up to its endpoint. How far? So in finding the height, we are going to use meters, and finding the range, we are going to use the unit meter. And for the angle of release, okay, for the angle of release, we are going to use the theta or the degrees. Okay, but on the angle of release, we are going to use the meter per second. So as you can see, there is an angle of release, the height, and the range. Okay, as you can see on that velocity, we have the velocity x and the velocity y representing the angle of release. Now, for us to really know how projectile motion is working, let us use this Phet Simulation. So how are we going to use the Phet Simulation? The Phet Simulation, the objective, relate the angle of release, the height, and the speed or the velocity of a projectile and its range. The materials, Phet Simulation, using laptops or tablet. Procedure, let us open the Phet Simulation link on your laptop using this link. And each Phet Simulation can be downloaded and be played on your device. So if you have some tablet, you may download at Play Store this Phet Simulation. Alright, so second, set the following condition. Now let us open this link first. Opening this link, so it is the link that show you once you click that link. So I will guide you or walk through on using the projectile motion using this Phet Simulation. So this is the intro. So we have the speed here and we have the object that is being projected. So after you open that, let us try this. Set the following condition. A. So what is that A? So as you can see, a golf ball, we are going to use an object golf ball as the projectile with an initial speed of 10 meters per second. Alright, so this is the initial speed. Let us adjust into 10 meters per second, and we have, okay, we are going to use the golf ball. Okay, if we want to use the air resistance, we want to see the velocity components, total components, just check those boxes. Alright, so this is the intro. Now for the vectors, so this is affecting projectile, the angle of release. Again, let us use this term. Okay, 10 meters per second. Okay, we may adjust according on the angle. Now on that part, okay, so while we're going to set up the projectile, we're going to use this. So let us set up the angle. Okay, these are the angle of release to the ground with a degree of 30, 60, and 90. Alright, so for the highest point, we were going to solve the highest point, the range, and the time, or the time to reach the highest point. Okay, now for the drag, okay, let us adjust into 10. So if we're going to drag, for example, 30, so we're going to use this part. So this one, so it is a part where you're going to see there's a time given, range, and the height, and this is a measure. We have the tape measure that this measure to measure from the reference point up to where the object is being landed. Okay, let's example 10 on the 30 degrees. Let us use the normal. So let us click this to drag. Alright, so there you have it. So let us see on that part. So we're going to use this one. Yeah. So as you can see, you will notice you have an answer or how far it goes. Alright, we have the time, range, and the height, and also this measurement. Okay, you're going to place this positive sign, this plus sign, okay, and this sign, and where it is being projected. Therefore, you have 7.45 meters. Alright, now, so let us answer this. Now, let us try this lab. Okay, now, let us answer this one. We have set in a 30 degrees. Let us set in a 30 degrees. Okay, 30 degrees, what's the initial speed? 10 meter per second. And what is the ball that we are going to use? A golf ball. A golf ball having a mass of 0.05 kilogram. The diameter is 0.04 meters, and with the gravity, so it is affected by the gravity, the 9.81 or 9.8 meter per second squared. Alright, so let us drag. Ready? 1, 2, 3. Okay, so let us use this one. Let us find the angle of release. Okay, so this one, we have that the angle. Now, so it is the angle of release. Now, what is the highest point reach? So highest point. So on the highest point, if you could see this green, this is the highest point, the green dot. So we're going to place this kind of bullet, like a bullseye, okay, on that green part. That is the highest point. So what is the highest point or the height? So we have 1.27 meters. So let us type in 127 meters. Okay. Now, what is the range? So the range, again, what is the range? It is the horizontal displacement from the reference point up to this, where it is landed. Okay. We may use this one, or we may use this one to find the range. Okay, the range 8.66 meter. Okay, or we may use this one. Okay, so let us place on this where it is landed. Okay, 8 point. Okay, we are going to use, we have 8 point on where it is landed, 8 point. Okay, we have 8.85 meters. Okay, we have 8.85 meters. And for the time to reach the highest point, so what is the time to reach the highest point? So meaning it is the time here, 0.51 seconds. So the 0.51 seconds. Okay, that is the highest point. Now if we're going to find the highest point in terms of range, so we're going to place this one here. Okay, or it is the times 2 or the double of the time in the height. Okay, so if we're going to double the range, or okay, how long that is travel, so we have 1.02 second for that, if we're going to look on the range. Okay, but this time we're going to find the time to reach the highest point, because that is the time where the ball is traveling. Okay, the highest point and the range. So 1 point, yeah, we're going that. Yeah, we have 1.02 seconds. Alright, so let us try 60 degrees. Okay, let us try 60 degrees. Let us adjust. Okay, let us adjust 60 degrees. Sorry. And 60 degrees, and same initial speed, 10 meter per second. Okay, let us drag. Alright, so first let us find the height, the maximum height. So what is the maximum height? So as you can see, the maximum height is 3.82 meters. So we have 3.82 meters. So what is the range, or how far does it travel? We're going to use this meter. So if you could notice, it is landed on the same as on the 30 degrees. So meaning we have 8.85 degrees. So what is the time to reach the highest point? So the time to reach the highest point is 0.88 seconds. Therefore, we have 0.88 seconds. Okay, then times 2 if we're going to double that range. Okay, to find this. Okay, to find the time on it. So we have 1.77. Okay, to find on that. Okay, we have 1.87 for the range. Next. Now, let us find 90 degrees. Yan, so 90 degrees is a right triangle. So with the initial speed of 10, same golf ball pa din. Let us drag. Release. Okay? Now, let us go back here. Let us place this one. Yan, so we have the maximum height of 5.1 meters. So we have 5.1 meters. And what is the range? The range is 0. Why is it 0? Because it landed on the same reference point. And what is the time to reach the height? So 1.02 seconds. So we have 1.02 seconds, the highest point. And for the range, same also. Okay, this is an example of projectile motion. Now, for your learning task 2, okay, for your learning task 2, so set the following condition using projectile motion. So using this table, set B, golf ball as the projectile with a 20 meter per second initial speed. So you're going to use this one, the 20 meter per second. So that is your initial speed. Therefore, you're going to adjust this initial speed. Okay, into 20. Okay, yan. And for the degrees, so you may adjust, so 30, 60, and 90. So, and find after you drag or release the golf ball, find the highest point, reach, range, and the time. On the set C, 30 degrees initial speed. Alright? Now, so after you do that simulation, you may find and answer this guide question. First, inspect the values you get. Second, how does the angle of release affect the height reached by the projectile? Third, how does the angle of release of the projectile affect the range? Fourth, which factor in the projectile's trajectory is affected when you change the initial speed? And fifth, how do you relate the initial speed of the projectile to the height and range of the projectile's trajectory? Alright? So, once your answer is done, so let us watch this video for the Palarong Pambansa 2014. So for your activity for today, after you watch this video, you're going to list down or identify the different sports where the projectile motion is being applied. So on that video, you're going to check those or list down at least 5 sports where projectile motion is applied. So how projectile motion works, there are factors affecting on it: the height, the highest point, the range, and the time, and also the angle of release. Therefore, in every sport, there's a physics applied, or in every sport, there's a science behind on it. Okay, look at that archery. So there's an angle of release, there's a projectile, and there's a range. Okay, so that is the physical sports. So when it comes to the e-sports, like playing Mobile Legends, there is a projectile applied also. If you could notice, some heroes are projected, okay, to dethrone, alright, to dethrone. And also, if you could notice, there's a range applied on it, there's an angle of release, there is a time, and there's the height to fire the torre, okay, of an enemy. Alright, so on your learning task 3, what are you going to do? So you may list down at least 5, and what are those sports you have been watched in the videos that are example of projectile motion. Okay. Now, on your learning task 4, let's have an assessment. Okay, so you may answer these questions. 1 and 2, what are the 2 dimensions in projectile motion that affects the angle of release? 3, it is the highest point of projectile. What do you call that? 4, it is the horizontal displacement in projectile. 5th, it is the objective presented under the influence of gravity. Value, when the time is right, I, the Lord, will make it happen. Isaiah chapter 60, verse 22. Just like in projectile motion, you need someone to release you or to push you to the limit to reach your goal. Because in the longest journey, it starts in every single step. And when the time is right, the Lord will make it happen. Thank you for listening. God bless and keep safe. For our references, so these are. Thank you and God bless. Alright, so thank you for listening. Have a good day. Bye.